The Bernoulli principle was found in 1738, when Italian scientist Daniel Bernoulli proposed that, as an incompressible fluid moves quickly, it exerts less pressure on its surroundings. This effect can be observed in a simple lifting paper demonstration, where I will take a piece of paper, put it on the edge of a table, and let its own weight pull it downwards. As soon as the air flows over the piece of paper, it starts to rise. It is sellotaped to the table, so no air pushes it from underneath. Even with a little bit of weight added to the paper, shown here as a little clip, it still rises, though rapidly, when I add air flown on top of it. So how does that occur? This effect arises from a pressure difference. I'll model pressure as collisions between the air particles and the walls or surfaces of our systems. Let me explain that. If we have a box full of air particles that are all moving in random direction, then some of those particles will occasionally bounce off the walls of our container. The walls of this box feel a force from all these collisions. Likewise, on our sheet of paper, we've got lots of air molecules that move in random directions. There are always going to be some that hit the sheet of paper and thus make a pressure on the sheet of paper. P1, or the collisions on the top, is equal to P2. Now, the hairdryer speeds up the air at the top of the sheet of paper. According to the Bernoulli principle, this would mean that the pressure at the top of the paper would be less than that of the bottom. Talking about the collisions, the air still moves randomly at the bottom, but more uniformly at the top, because it is going quickly from right to left. This is due to the hairdryer speeding up the air at the top. Hence, there are going to be more collisions between the air particles and the paper at the bottom than at the top. Because there are more collisions at the bottom, the pressure will be greater at the bottom than at the top. This pressure difference is a greater force than weight, so it will make the paper rise until both forces are equal.